Now, let us discuss about normal distribution. Normal distribution is a form of probability distribution. We have already discussed about probability distributions, and we know for a fact that if we can represent probability on the y-axis and random variable on the x-axis, it would be called as probability distribution. Here I'm trying to plot heights of people, right? Heights of fully grown individuals, that is heights of people who are who have greater than say 30 years, who are greater than 30 years, right? That is what I'm trying to understand here. And here I'll be plotting the heights of the people now. We will have people with 1 feet, 2 feet, 3, 4, 5, 6, 7, 8, 9, 10 feet, so on and so forth. Yeah. And probability values always range from 0 until 1. So say you have 0, 0 0.1, 0 0.2, so on and so forth until 1. Right. Now, if I were to explain you normal distribution, this is how I would do that. Probability of finding people whose height is 1 feet. I'm speaking about fully grown individuals whose age is greater than 30 years. Finding individuals whose height is 1 feet is extremely low. The probability associated with finding people whose height is 1 feet is negligible. Probability of finding people whose height is 1.5 feet would be slightly more than 1 feet, but still it's negligible. Probability of finding people with 2 feet height is still very less, but it is slightly more than probability of you finding a person with 1.5 feet height. Probability of finding a person with 3 feet is slightly more than probability of finding a person with 2 feet. Probability of finding a person with 4 feet is slightly more than probability of finding a person with 3 feet. And 4.5 feet will be slightly more, 5 feet will be even more, 5.5 will be even more, then you'll have 6 feet, 6.5. And now if I start increasing the heights of the people from 6.5 feet onwards, it will keep reducing. 7 feet, it'll be very less, right? 7.5, 8. It keeps decreasing in that. And if I try to draw a curve in that way, connecting the peaks of all those bars, it appears as if it is normally distributed. It is normal to find people, or to find majority of the people whose height lie between 4.5 feet to 6.5 feet. It is normal to find majority of the people whose heights range from 4.5 feet to 6.5 feet. However, it is also normal that the probability associated with finding people whose heights are 1 feet or 1.5 or 2 feet is negligible. It's very less. And it is also normal to have negligible probability associated with finding people whose heights are 8.5 feet, 8 feet, 9 feet, 10 feet, so on and so forth. So all this is normal. I do not see any abnormality here. And hence, this probability distribution is given a name called normal distribution. Everything is normal here, right? Weights of the people, heights of the people, any naturally occurring event on the planet would follow a normal distribution. There are a few properties associated with normal distribution, and the first property is that the probability associated with a single value of a random variable is always zero. Why is it always zero? Even before I explain that, let me first try to explain this point. The normal random variable takes values from minus infinity to plus infinity always. So theoretically speaking, your random variable values range from minus infinity to plus infinity. You just get a sense that it's touching, similar to your sky touching your land. That is what you feel, but it doesn't touch. So theoretically speaking, it ranges from minus infinity to plus infinity. If you're, okay, this is first part. The normal random variable takes values from minus infinity to plus infinity. Second, the probability associated with any single value of a random variable is always zero. If I ask you to find out the probability of you finding a person whose height is 5 feet. So I'm interested in finding a person whose height is, say, 5 feet. What is the formula for probability? Formula for probability is number of interested events divided by total number of events. So the number of events here we are discussing about is only one event, which is 5 feet. So number of interested events is 1 divided by total number of events. How many events do we have here? If normal random variable ranges from minus infinity to plus infinity, you'll have infinitely many possibilities. So the total number of events is infinity. And 1 by infinity is equal to 0. So the probability associated with any single value when it comes to your continuous data is always 0. Another statement is area under the entire curve is always equal to 1. Under this curve, you can theoretically find all the human beings, right? None of the human beings' heights would be beyond minus infinity or above plus infinity there. Never, right? If you're trying to plot profits of your organizations, and if I say that this curve would contain all the profit values ranging from minus infinity to plus infinity, what does that mean? This means that 100% of the values lie under this curve, right? 100% is equivalent to 1. If you want me to represent that in number format, 100% is equivalent to 1. These are the 3 statements pertaining to normal distribution.